How's everybody doing today? Thank you for joining us today for our Oxygen 8.1 webinar. This is round 2 out of the 2 rounds that we're doing this go around for to talk about the latest and greatest release of Oxygen and the new features that we're releasing in the first minor revision and major revision Oxygen 8 for this quarter. So, hi, Tyler Dahl. I'm the sales manager for the East Coast here for DEWETRON, and I'm joined by Malik Mukdadi, who is our applications engineer out of the Austin, Texas office. So we got some really cool stuff to share with you guys, but first, before we kind of dive into the topics, I'd like to remind everyone that we will have a couple of polls throughout the presentation here that'll kind of pop up and you'll have access to, and we'd love to hear your feedback on that. I'm going to ask, like what version of Oxygen you're currently on. And an important one that we'd really like to hear from you guys is which feature that we talk about today are you most excited about or most likely to use? And of course, at any time during the presentation, if you have any questions, please feel free to drop that in the Q&A section, and we will either answer that on the fly as we can, or if it's something super good that we can't answer at the current moment, we will definitely get back to you via email. All right, that being said, so our topics for the day. We're going to talk about something I'm super excited about, which is the OPC connectivity that we have now, along with the Modbus server modifications that we've made. So the enhancements from the original Modbus abilities or capabilities that we had before. We'll talk about phase synchronous statistical channels, our new kind of extended digital output functions that we've added. We'll talk about some of our new usability features, real-time power, which is also another cool, really cool, super exciting one that a lot of people are excited about. And then the Python support that we've added for our SDK and our ODK. So to kick us off here, Malik's gonna start talking about our 2 new new and improved, so both, server options or communication protocols.
Thanks, Tyler. So first I'll start with introducing the OPC-UA capabilities that we have integrated in this Oxygen feature or release. For OPC-UA, we've integrated both a server and a client side that you can interface with in Oxygen. And with Modbus, we've done the server side since we've already had a Modbus receiver plugin in our previous releases. So let me dive into the server side for OPC-UA. The architecture that we have going on here mimics or is very similar to a publisher subscription architecture. So our server here in Oxygen, if you set one up for OPC-UA, will act as a publisher and have publisher functionality that you can then connect from any client side within or outside of Oxygen and DEWE systems. To set up an OPC-UA server, you'll have to navigate over on the right side into the measurement settings, expand it out, and you'll find under the settings a selection or an option for servers. In fact, you will find both the Modbus server and the OPC-UA server. I will talk more about the Modbus server a little bit later in this presentation. So for now, let's focus on the OPC-UA. When I expand out, open the server option for OPC-UA, you will see that I can add or delete an instance of a server. Right now, I already have one here. So it's already been added. As soon as I select it, I can delete it. And I have it running currently. So let me go ahead and stop it so I can show you the available configurations that we can do or utilize with setting up a server. So as with any server, you can set up the port and the update rate. This lets you set up how to access the server, as well as how often those values are updated or published out into the open for the clients to receive. We can also select what statistics mode, basically what values that we want to send from our channel selection here. And these modes include the last value, the minimum, the maximum, the average, and the RMS value. Over to the right is the option to select the channels that you want to publish out from the server side. And you'll find here that we've selected a few channels already, but all of the channels that you have on your DEWE system or the chassis itself is available here. Let me go ahead and get that server running up again before I transition over to talk about the client features that we've integrated for OPC UA. So here we have all of these channels actually being read in from the client side of things, and they are streamed in as if they were native Oxygen channels. So we have a few key features here on the client side where you can set up the time to either be the client side or the server side time base. This is configurable. You can also set up the publishing interval, right, as you got from the server side of things. Be able to monitor whether the server is up, whether you have a good connection or not. A couple of endpoint features for saving, loading, and exporting them. That way, if you have multiple systems you want to connect to one singular server, it's as easy as copy and pasting. There are also some security and authentication features on the client side, so that if you want to be a little bit more careful about how to connect to the server, we have those options available for you. And of course, more information on the channel selection, specifically the properties and the metadata that are available for those channels. So let me go ahead and show you how to set up an OPC UA client within Oxygen. You'll go ahead and go over to the Data Channels tab, expand that out, and then from the bottom left where you have the Add Channel button, I have it favorited already, but if you search up and find the OPC UA client plugin, you'll be able to find where you can import or add in that software channel. Here you'll notice that I can already import a CSV for my configured endpoint, making it very easy for me to go from system to system and setting up these endpoints very quickly on the fly. Or if I don't have one yet, I can manually add one myself. So I won't go ahead and take time to type one in, as I've already had one set up here, and I'll go ahead and show you what it will look like after you add the channel. So here I've configured it to the 4840 port that I had from the server, as well as setting up the time source to the internal time. So this is the client side time, but I can switch over to the reported time or the server side time. I've matched the publishing interval to 100 milliseconds, the same that I had on the server side. And currently I did not implement any security or authorization, but these are options that you can implement if you have more higher security requirements for your setup. You'll see in the bottom left here that I have a connected green status that shows me the status of the server and the client, that I do have that line there. And if I want to do a little bit more, look into those channels a little bit further, I can expand out from the Oxygen. These are the channels that the server is publishing. I can look into that metadata, right? Those properties of those channels as well, looking into the factor, the offset, the sample rate, so on and so forth. So this is pretty exciting, seeing how we've set up both sides for the OPC UA server. We've decided to also set up, as you're familiar, we have the Modbus receiver that acts similarly to the client, and we've decided to add the Modbus server so that we can have both protocols fully supported within Oxygen. So if you recall, over in the measurement settings, whenever I go to servers, you'll notice that I had the Modbus server already set up. And it's very similar to the OPC UA server in terms of the configuration and the channel selection tab over here, with a little bit of differences in terms of how I can configure my server. So instead of having just a port, I also have an IP address for Modbus. I also have a buffer duration, so how long I want to wait, as well as a unit identifier, and I can save the config as much as I'd like. One thing I would keep in mind is that the statistics mode for Modbus is limited compared to the OPC UA server, where we don't have the min-max RMS. We only have the last value and the average available to us for the Modbus server. So keep this in mind in terms of which protocols you want to go with for the communication. We decided to offer both as many clients, so as many people are from different industries utilizing different types of protocols. So these are some pretty cool server stuff that we've got set up. I think this really applies to a lot of different industries out there. I can think of a few. Do you have any ideas, Tyler, on what industries would utilize these servers?
Yeah. So with this extra added connectivity, I mean, pretty much any industry you can think of, even some industries that maybe we haven't traditionally been in the past. So for me personally, like I said at the beginning, I'm really super excited about the OPC UA functionality. So all of our Oxygen users out there, all the DEWETRON system users out there, are at some point sending information or data to their data people who are then using an analytics package, a machine learning package, or something along those lines to analyze that data. Well, guess what? A lot of those packages utilize OPC UA as a potential data connection. Now, instead of having to export or port that data and then move it manually like that, which is still pretty easy to do with our DEWETRON systems and with Oxygen, now it's that much easier where you can actually live stream that data directly into those analytics packages. And I mean, I'm all about data, right? So just being able to get that information into our Oxygen systems where you can have everything, which we all like, in one central location, which we're really good at, or out to other packages or other software packages that our users are currently, utilizing as a part of their everyday tasks that they're performing. So this is great. I mean, there's not an industry I cannot think that this would not fit into, honestly, Malik.
Right,
So
right. I do see a question from Andreas. I wanted to just, sorry if I butchered the name, but I did want to answer it very quickly because I think it's a very good one I didn't touch up on. And he asked if the OPCUA connection is lost, does it reconnect automatically? And so, yes, it does. Just to show you really quickly, if I go over and I disconnect the OPCUA server, I turn it off, I can go over and see that the connection check is in progress and it's not reachable. When I go and set it up again without me having to touch anything, it will automatically, if I can catch it in time, well, I didn't catch in time because it's so quickly, but you'll see that it's automatically connected by itself. So as long as I have the correct endpoint set up, it will automatically every time I restart my acquisition, it will automatically connect to the server.
that's really cool stuff. And that just shows even how much more powerful it is right there. So that was a great question. All right. So moving on. So Malik, why don't you tell us a little bit about phase synchronous statistical channels and also our extended digital output functions?
Sure thing, Tyler. Thanks. So we have decided to expand the calculations that we can do with our statistics channel. If you're familiar with that before, we were using these channels to do, various statistical analysis, averaging, RMS, rolling, so on and so forth of channels. And we've decided to expand that over for these waveforms or analog signals that you may have that you want to be a little bit more careful about their phases, right, their periods or their frequencies, if you will. So let me just jump right into how to set that up. If I go over to my add channels here and I select, before I do my add channels, if I go ahead and select an analog signal, so I'm going to go for, say, source, right? And I go and I add a statistics channel for this. You'll notice here, if you're familiar with our statistics software feature functionality, is that we have added these two new statistics analysis. However, they are blocked off because they apply to phase locked measurements or phase locked calculation types. So what we've added here is, along with all of our other calculation types, is that phase lock calculation type where you can do all of these statistical analysis depending on the phase of that channel. This includes being able to select a channel for the period source. In this case, I've selected my source channel. as well as setting a trigger level, whether that's rising or falling edge, a rearm level for that. And then my statistics window, whatever calculations I'm doing, will be based off of the period or the frequency of that waveform or wave signal. So I've already added one up here, and you see here that I can do my RMS, my min, my max, as well as read the frequency and the period time for that signal. And I can run that right now. I'm only running it off of one period, but if you're having some noisy work or you're working with some waveforms, some signals that aren't very steady throughout each period, you can do more of an averaging, if you will, across those cycles. And then on the digital side of things, we've decided to add some more advanced functionality for our digital output. So if you're familiar with our chassis, we have a digital input output plug that you can interface with. Typically, this will be a DB13 or a DB connector. And for our digital outputs, previously we were just doing a digital level output. Now we've supported more of a continuous signal from that digital output pin that includes a frequency clock. This is just a clock signal that you can configure from 1 hertz up to 10 megahertz. A PPS signal, so this is a 1 pulse per second signal. These are great for a few motors or a few sensors out there. We also have a dedicated clock 10, so this is a very much more dedicated continuous 10 megahertz clock signal. As well as some synchronization for IRIG-B. So if you have, you're using IRIG-B to synchronize different systems, now you can import that or forward that signal as a digital output from your DIO on the chassis and be able to see that or visualize that as a software channel in Oxygen. We've also added the aux software channel pin available as a software channel in Oxygen, and this is where you can see that sync, the IRIG-B that I mentioned previously in Oxygen itself. So let me go ahead and show you guys what that looks like. If you go over to the DIO on the system here, you'll see that I have all my digital inputs, and then from my outputs, I've configured different modes for them. So if I go and select my setup, I can see that my modes have expanded from not just digital output, but to include those 4 modes that we've talked about. Over here, you can see the aux channel. If I close my settings, you can see the aux channel down here with the IRIG. And if I had an IRIG signal coming in to the system, I would see that here as this channel. So now I can drag and drop it into my measurement screen very easily. So these are the digital/analog functionalities that we've added onto our Oxygen software. I think these sound pretty cool, pretty interesting. What are your thoughts about this, Tyler?
So I think it's awesome. So with the phase synchronous functionality that we've added, so we already had the ability to pull in frequency data or frequency information, but this makes it that much easier to find, making it part of the statistics channels. But also, I really like the fact that you could smooth it out now. So just, as a native property of our hardware, because it is such high quality hardware, I mean, especially you're going to get chatter, you're going to get, movement across that as you get that, high speed, highly granular data coming across. So you're going to pick up everything, which you may not always want because it can be a bit of an eyesore to see that chatter as it's going around, that main frequency that you're trying to pick up. So this allows you to really smooth it out, to just make it a little bit easier to work with, a little bit easier and better to look at as you're kind of going through your testing. And then with the digital out enhancements that we've made, this is also very cool. I mean, so now we have the ability to essentially propagate timing signals further down the chain through our system. So our systems will natively synchronize with themselves via our Oxygen Net features. But now you can actually propagate that same signal that our DEWETRON systems are utilizing to other third-party systems. So say, for example, you only had one IRIG connection. Well, you can plug that into your DEWETRON system and then use that DO port to actually propagate it out to the next system that's a non-DEWETRON system that would need that timing to synchronize those external sources with our system. So really, really cool stuff. And even the ability to, create your own sync signals or your own output signals. That's really cool too. I mean, our team does an awesome job of putting these updates out. And I said this before, I'll say it again, I'll say it every time. Oxygen is for the user, by the user. This is all based upon your guys' feedback. So what you tell us is what we implement into the software. So what you need, we do that, and we try to implement as much of that as we possibly can. So if you ever have a feature you'd like to see implemented, something you'd like to see improved or maybe tweaked or changed a little bit, do not hesitate to reach out to us. We love to hear from you. We love that feedback, and we'd love to implement it even more. So, Malik, now we're going to talk about some of the kind of improved quality of life features that we've added to Oxygen. And then, are you going to tell us about real-time power yet?
I think I'm gonna leave that for dessert a little bit later. So we'll get through the quick access stuff first, and then I really wanna end it with a bang with that power, real-time power analysis. So
we'll
stay
be
patient with me, and we'll get there. So let me just hop right into it then. We've added a couple of miscellaneous, really more so quick access and system updates. Like Tyler said, right? Oxygen's for the user, by the user. We really want to make sure that as we continue adding all of these new improvements, these new ideas, these new plugins that can be utilized for more complex applications, that we keep Oxygen itself simple enough to interface with so that it's more intuitive, giving you more of those, that makes sense kind of moments. So the first thing that we've added, and this honestly, as an application engineer using Oxygen every day, this might be my favorite, right? This is a quick access for those frequently used like calculation channels. So every time you go to the add channel menu, right, you always have to hit the add button and then go look for whatever plugin or whatever calculation that you want to do. However, if you favorite up to 4 channels or 4 calculation plugins, you will see them now show up at the bottom of the channel list down here. So for me, whenever I'm working, I really want to keep up the flow. If I want to add like a lot of formulas back to back to back, I now have the option to configure this quick access, right? This quick button that I can just click and then keep moving forward. So really, really big, as somebody who uses Oxygen very often, I really like this addition a lot. We've also now added more support for Skippy, specifically in the number of connections that we can hold through Oxygen. Previously, it was very much a single connection, host to client. Now we've expanded that into parallel connections where you can have multiple clients to a single host. So this is really useful for those who might have automated testbed systems. We have multiple systems going on, or maybe if you're even using Oxygen's Go and you want to have more of a monitoring and measuring at the same time to one consolidated host, we are now able to support that with the release of 8.1. Another thing that we've decided to add is if you really work into the measurement screen heavily, you don't like to jump back and forth, especially if you're using recorder instruments. We've decided to display the absolute or the relative time directly within the instruments. So we've been expanding a lot more on the functionalities in the measurement screen and how quick you can get the information that you'll find useful within that. Previously, if you go to the recorder and then you'd have to look at the time format, and that's now integrated there. To make sure that you see that time format though, make sure that whenever you're setting up your recorder instrument that you have the show time format button selected so that you can see that there. We've also added a screen lock behavior. So if you're setting up an XCP connection, getting it established, now the screen lock is automatically disabled. So this is a nice one for those who do use XCP often. And then for our resolver plugin, we have now added a configurable filter length. So if you're working with that velocity angle for maybe like a rotating shaft, You want more of improved signal quality, something more of a smooth speed output. This is what that filter length really helps out with. And then, as you saw with the Modbus, we supported output modes for last value and average. We've decided to take this and apply this for can out as well, so it did not feel alone with that. So now we have these output modes for can, as well as the smooth speed output for the resolver. So I'm going to show you really quickly what that looks like. Here I have a resolver plugin already set up, and you'll notice that along with my other property options that I've had here, that I now have a filter length up to 1000 milliseconds that I can set up there. So that helps me with achieving that more of a smooth speed output. And then if I go over to, say, a can signal, let me find it here. Oops, scrolled right past it. Now I can either look directly into my can signal. I'll see my output mode there, so that I can select between average or last value. Or if I just go to my messages and signals, I can look at my signals in here and see the output mode there as well. So yeah, these are some nice quick access, right? These are very much more so like user accessibility updates that we've made. I think this makes Oxygen a lot more intuitive, a lot more easier to use. What are your thoughts about this, Tyler?
I love it. So, especially one thing that I really like about this feature set that you just talked about is the parallel Skippy ports. So, I think everyone on here should know. So, we just released Oxygen Go, which is our mobile app that allows you to view your test data and even control your test rig from your cell phone or from your mobile device. So before we only had natively one Skippy connection, and that app, if you were utilizing it, would essentially consume that connection. So you had the back and forth because that's how the app communicates is via Skippy. Well, now with this parallel connection, now you can utilize the Oxygen Go app and still utilize that Skippy connection to external devices to pass and receive data or pass and receive commands, which is huge. And even so, if you wanted to use, a DEWETRON system as a more powerful kind of controller, now you can actually utilize those Skippy connections to multiple sources. So you can send one to in this direction to this device and send the other connection to a completely different device. So just a bunch of really cool stuff there. And of course, like Malik said, from the engineer's perspective, just being able to favorite and have directly there at the top what you're looking, your most commonly used tools. So all of that is really cool. And like I said, everything you see here, these were implemented by your demand. So by the demand of users of Oxygen like yourselves. So reach out if you see something you want to add. I mean, let us know. And then as you kind of see these features, so this is Oxygen version 8, so major revision 8. If you feel that, these features make sense or would help your workflow and you're running an earlier version of Oxygen, don't hesitate to reach out to us directly, to the sales team, whoever that be, to help you out to see if it makes sense and what an upgrade looks like for you. It's important to note that every minor revision within each major revision of Oxygen is at no cost to our customers. So if you have Oxygen version 8, you have access to 1, 2, 3, and so on, all the way up until we do the next major revision of Oxygen 9. All right, Malik, now can we hear about real-time power?
I think I've held back enough. So, I'll just dive right into it if that's okay with you.
Go for it.
All right. So we have now expanded our Power Groups functionality to include the capabilities to do real-time calculation. So if you're familiar with our Power Group before, we would take in voltage and current inputs, couple phase inputs, and utilizing those, we were able to calculate power factor, see the waveform data of input channels, and we had some expanded functionality that we included as well. such as DC power values, being able to see mechanical power efficiency, so on and so forth. We have now drawn that over to real time with some key things to keep in mind if you want to utilize this. So to make sure that we don't have any bottlenecks when we come down to wanting to get this real-time analysis, we have released this onto the Oxygen version on Linux, specifically due to the caveats that come in between the two operating systems. So as you may be familiar, Linux itself is a much more lightweight, less intensive operating system software-wise when compared to Windows. So therefore, it's a lot faster, has typically less latency as it's not spending so much time on the processes and the background software operations that you might have noticed if you use Windows often, right? No annoying updates coming up out of nowhere. And so this is specifically on Linux on the Ubuntu 24.04 distribution. And we've been able to achieve a typical IO latency of 2 milliseconds. So it really gives you that real-time feel. It is quite quick. And if you do want to output these values, we have implemented support to do that via UDP. So same concept there in terms of the bottlenecking. We don't want any, or we want to reduce as many bottlenecks between the Oxygen software to the actual hardware. So we've decided to go with UDP as opposed to TCP to really uphold that low latency. So this can go up to a 1 kilohertz update rate, and you'll be able to see all of these channels, all of the configurations within the new real-time tab in that power group. So let me show you what that would look like. First and foremost, before you go and jump into making a power group, be sure that you go over to your Oxygen setup. Over in the DAC hardware setting over here, you'll see that there is an enable real-time computation settings. Make sure that this is set to true as it sets the hardware to be prepared for all that real-time calculation or real-time just grabbing those samples so that it can keep up with the real-time calculations. And then when you add your power group in, you'll notice over in the settings section for that power group, along with the advanced settings, we have harmonics, flicker efficiency. Now we've added real time. So you can enable your real-time calculations, set up the cycle rate, set up the averaging, excuse me, set up the averaging across the period. So how many periods that you want to average across, set up the UDP output. So of course that will include the IP address or the port to connecting to that, and then the actual output channels that you want to interface with. So that's not only just the voltage and the current, but the calculations of the power, the efficiency, so on and so forth. Once you add your power group in, you'll notice then that you will have two sets of power groups, one of the normal set that you're most likely familiar with already, and then the new set of the real-time groups that you see over here. So you still have access to both the normal set as well as the real-time set, so you can utilize both for your purposes or for your measurements. I do want to keep note of the fact that this applies for all of the wiring types except for the other wiring types. This is because the open-end, the nicheness of the other wiring types and being able to support up to 9 phases has kept it, we have kept it to only being applied to the default setups that we have here. And that will conclude most of our real-time power analysis stuff. Pretty exciting stuff. I do have one more thing to talk about, but before I do, I know you're really excited about this, Tyler. So let me know your thoughts about, this new addition to our power group calculations.
All right. So I'd like to preface this with, this is because of our hardware that we're able to do this, right? We're doing the filtering at the hardware level. We're doing the switching at the hardware level. We pride ourselves in high quality hardware here at DEWETRON, and that's what allows us to do this. There's other guys out there who are doing software filtering and other tricks like that, And so they're digitizing all that noise, all that garbage. They don't have the headspace on the CPU to be able to do this, because we're not only able to send out the raw values via this new real-time power functionality, we're able to send out the calculated values as well. So that just speaks to the quality of the hardware, and that carries over into the abilities within our software and what we're able to do. I mean, this is really cool stuff, and it allows you to port that data out to external sources via that fast UDP connection, so that you can have that real-time power data at the other sources that you may need it, or it may be important as a part of your testing process. So to me, this is a big deal. And like I said, this is a testament to the quality of our hardware. All right, so we are almost done here. So as we kind of complete this out with our last topic, remember the polls that we're sending out over here to everybody within the presentation. And the one that I'd really like to hear about is, which feature are you most excited about? Which feature would you be most likely to use, or would your customers be most likely to use? Because that's what allows us, or shows us kind of what to focus on and how to better support everybody out there. So with that being said, Malik, why don't you tell us about our SDK ODK enhancements that we've made?
Sure thing. So I'll wrap it up with some more of our software capabilities that we have implemented, specifically about our SDK. So if you're familiar with Oxygen SDK, it is the capabilities that we have added to keep Oxygen very open-ended, keep it very modular, so that you can come in with your own custom requirements and interface with it to achieve what you need to achieve with the hardware that we provide. So this is what our SDK has been. We've been supporting it with C++ so far. So you'd be able to, with Visual Studio, get a plugin going and make your own custom plugin, custom calculations, so on and so forth, all within C++. And we have decided to expand that outwards laterally into other programming languages, specifically Python. So we've now brought in the core capabilities that you normally have with the C++ Oxygen SDK, now in Python. This is including being able to register new channel types. So whenever you go to the Add Channel dialog, you want to make your own plugin, you want to make your own calculations, that's there, capable for you. You can add output channels, so with custom properties. So if you want to make a calculation in a certain type, you want to output it so you can interface with it with a third-party external system, or in some specific format that you'd like, this is a possibility as well. You can even customize the channel detail pages. So with QML, you can make sure that it looks nice, the UI really fits your need. And of course, that includes the property names, the UI text as well. Now, the differences between the two languages, between Python and C++, do exist, right? And so the features that we've implemented have been catered towards those core functionality differences between the two. For instance, with Python specifically, because you have the interpreter overhead that you can interface with, the plugins can run in a separate process. So then you can keep Oxygen stable while you have your plugins running. So if the plugin is to break, if you're still want to troubleshoot, you're still in the testing phase, you don't actually have to make an impact on Oxygen itself. The plugins can be auto-started by Oxygen, or because they can run on a separate process, you can run them in a separate debugger for development. So this really helps with smoothing out the process in terms of creating your own custom calculations. And then the support that we've brought on for Python has been for Python 3.12 to 3.15. That also includes NumPy 2.x. And so, because the languages are different, I do have to mention, or I do want to mention, the considerations between the two, right? Lowering the performance compared to, you'd have lower performance compared to like equivalent C++ plugins. C++ being more lower level, it's much easier to keep it quick, whereas Python has that impact, right, from the interpreter overhead, and that causes limitations with multi-threading and data transfers. So make sure to keep this in mind whenever you come to considering which type of language you want to go with when creating a custom calculation channel with our SDK. As always, we have all of our additional documents available on our publicly accessible GitHub. So be sure to go ahead and give those a read, as they've gone way more in depth than I have in terms of the functionalities and the capabilities that we have here. And that'll wrap up our presentation. Thank you so much.
Awesome. Good stuff. Thank you, Malik, so much for, all of the information that you shared there. Excited as always. I mean, pretty much every time I'm excited because we're always rolling out really cool new features. So I'll give a last chance to ask any questions from the audience here to see if there's anything that they'd like to ask before we close this out. But in the meantime, so talking about the SDK ODK, our software is very powerful, but we're not providing you just a black box. So with our SDK and ODK, even though Oxygen is as powerful as it is, at that point, utilizing those capabilities within our just technology sphere, it's purely imagination limited at that point. You can use that SDK, that ODK to create your own plugins, create your own connections, whatever it is, whatever your heart desires, you can actually do that within those platforms and create functionality that we haven't even thought of yet, or that is special specifically to your test setup. So it's just really cool stuff. And I think it's very important, and Malik touched on this, is the fact that we run it as a parallel process to Oxygen. So that's huge as far as it comes to debugging, especially. So you can actively be running Oxygen, and if there is an issue with your plugin that you've created, you can actually live actively troubleshoot that while Oxygen is still running. So that's just really cool stuff. So that being said, we'd like to do a call to action. So if you have not signed up for our newsletter, please do so. There's a link to that actually here inside the interactions. You'll see on the right-hand side of the presentation here. And please sign up. That's how you find out about new features they're releasing, news going on at DEWETRON, new hardware they're releasing as we continuously upgrade and update our hardware and refresh it. We did have one question come in. Let's see. What is your experience using AI Vibe coding for Python, the new Python ODK? Malik, can you speak to that one?
So it is possible, right? As long as you're using Python for your, building a plugin, that is always an option, right? There is no block within Oxygen against vibe coding. I do my own software development as well, and I do utilize AI to support me in terms of question debuggings and whatnot. So it definitely is a possibility. Just be careful. I think utilize everything that Oxygen provides you to ensure that you can debug effectively. So being able to have it run in its own process, so that you don't have any hiccups that might come up and then end up being maybe the AI's fault for not having the proper foresight that it should. So I definitely would utilize it for Python. Ensure that it is in its own separate process. That way it doesn't make impacts on Oxygen itself. So 100% good question, 100% very possible.
Yep, good question, and thank you, Malik. That was a great explanation. So that being said, we're coming up at the end of our time here. So like I said earlier, if you need to reach out to us, want to reach out to us, just even say hi to the DEWETRON team. Do not to reach out to us. You can always go to our customer care portal. If you're not signed up there, please do so. That's also how you can sign up for the newsletter as well. That's ccc.dewetron.com. And that's where we also store all of our Oxygen downloads to get the latest and greatest version of Oxygen, along with a lot of other cool material that you would have access to at that point. So I think we've answered all of our questions. I appreciate everybody's time. I appreciate you listening to us, and looking forward to the next version that we release of Oxygen and all the exciting new features that are ready to come out with that. All right, everyone, enjoy the rest of your day, and talk to you later.